All right, my name is Zachary Garner,
And I'm Alexandru Szilagy.
and we are doing the characteristics of healthcare coverage in the United States for our final presentation in ECON 495. So there's a little bit about why we chose this topic. We want to understand the relationship between insurance coverage and a number of variables. We also want to understand why some individuals are insured while others are not. Our data analysis will help us find what characteristics make insurance coverage more likely. And insurance coverage is a highly contested political debate right now. So understanding the data behind it has been an interesting topic choice. This helps us understand any future or past legislation regarding health insurance or healthcare. There's a little bit of our background research. We're primarily using two pieces of research. The 2020 health insurance coverage in the United States. This is a population survey. This research also includes the data that we will be using for our analysis. We are also using the CPS health insurance definitions from May 2010. So our hypothesis is really that there's differences in insurance coverage. We believe that certain characteristics can uncover the likelihood of health insurance coverage. Certain variables will have a positive or negative impact on an individual's likelihood of insurance coverage. For example, age would be expected to have a positive sign because as age goes up, health can become a problem. Therefore, an individual becomes more likely to have health insurance at an older age. Next, we'll talk about our data set. So our data set is collected from the U.S. Census Bureau. This is a 2015 to 2019 American Community Survey. This survey contains key variables such as age, gender, income, employment status, education, and race. This also contains information about whether an individual is an insured or not. We will utilize key variables within this data to form our final project. And we simplified the data set to make it easier to work with in Stata. This includes using the important variables needed to examine our hypothesis. So this is our model with variable descriptions. Our dependent variable is insured, and our description is whether or not an individual is insured. Now we have our independent variables, which include age, sex, race, education, employment, and income. For age, we have our numbers going through 1 through 7. So this will be 1 if an individual is under 6 years old, 2 if an individual is 6 to 18 years old, 3 if they are 19 to 25 years old, 4 if they are 26 to 34 years old, 5 if they are 35 to 44, 6 if they are 45 to 54, 7 if they are 55 to 64, 8 if they are 65 to 74 years old, and 9 is 75 years or older. For sex, it will be 1 if the individual is a male and 0 if the individual is a female. For race, it will be 1 if the individual is white alone, 2 if they are Black or African American alone, 3 if they are American Indian or Alaskan Native alone, 4 is Asian alone, 5 is Native Hawaiian and other Pacific Islander, 6 is some other race, and 7 is 2 or more races. For education, 1 is less than high school grad, 2 is a high school graduate, 3 is some college or associate's degree, 4 is a bachelor's degree or higher. Employment is 1 if the individual is employed, 2 if they are unemployed, and 3 if they are not in the labor force. And income is 1 if the individual is making under 25,000, 2 is 25,000 to 49,999. 3 is 50,000 to 74,999. 4 is 75,000 to 99,999, and 5 is 100,000 and over. So now here are descriptive statistics. Here we can see our descriptive statistics in the form of a table. So for insured, our mean is 91%. For age, we can see that it is 4.8. So the individual or the mean of our data set is around 34 to 44 years old. Sex is 0.48. Race is 1.72. So primarily our data set is white alone or Black or African American alone. Education is 2.57. So this would be somewhere in between high school graduate and some college degree. Employment is 1.47. So we can conclude that it's about, it mostly is employed individuals. And for our income, it is 3.02. So this would be an individual making somewhere between 50,000 and 99,999.
Next, we have the correlation coefficient matrix. Here, shown in this image is the correlation matrix between insured and our other variables. So there is a positive correlation between insurance and the education of the person. Also, there is a positive correlation between insurance and the income of the person. There is a negative correlation between insurance and the employment status of the person, but because the level of statistical significance of the correlation coefficient in this example is 0.264, this means that there is a statistically insignificant relationship between insurance and employment. Next, there is a positive correlation between insurance and the age of the person, but because the level of statistical significance, the p-value of the correlation coefficient in this example is 0.34, this means that there is a statistically insignificant relationship between insurance and age.
Next, we have
the correlation scatter plots, and Zach is going to talk about these ones.
Perfect. So here we can see in the first one is insured and education. So we can see that as education goes up, insurance becomes more likely. For our second, we can see insurance and income. Like was mentioned in the last slide, these two are positively related. So as the income goes up, the insurance coverage most likely goes up as well. Same with insurance and education. I repeated those two, but we'll continue. Next is insurance and employment. We can see that as individuals get closer to not in the labor force, they're less likely to have insurance. Then we have insured and race. And finally, we have insured and sex.
Next, we get our empirical results. We have three models here: the linear probability model, the logit model, and the probit model. We start with the first one, and first we are going to talk about the linear probability model. Here, for variable age, 1.6% are less likely to be insured. For variable education, 1.4% of the people are less likely to be insured, and for variable income, 7.7% are more likely to be insured. Next, we're going to talk about the probit model. Here, for variable age, 1.1% of the people are less likely to be insured. For variable education, 0.5% are less likely to get insurance. And for variable income, 5.2% are more likely to be insured. Conclusion and solutions. So our data analysis, like the one we have shown, allows for better policy solutions. Policies such as universal healthcare are proposed to help insurance coverage become more attainable. And this data set showed us what characteristics of individuals are less likely to have health insurance. And the average of predicted probabilities to have medical insurance for the study sample is 91.18%. Here is our works cited. Thank you for watching our presentation.
Thank you.